Hey everybody, so now we're going to be talking about tangents. Now, a tangent line intersects at a circle at exactly one point, and that's called the point of tangency. So in this case, that would be point A. Now, a line is tangent to a circle if and only if it is perpendicular to the radius that is drawn to the point of tangency. So that's why you see this right angle here. It needs to have that. All right, so let's try it out and apply both of these theorems and definitions. All right, so the first one says determine if this line right here, xy, is tangent to point z, to circle z, sorry. And we can name a circle just by its center. So we need to see if this is a right angle, and notice that we're working with a right triangle. So we're going to use everybody's favorite theorem, and we're going to use Pythagorean theorem to check if it is actually a right triangle or not. If it is a right triangle, then it'll equal up. So let's find out. If this is 8 squared plus 10 squared is equal to, and your C value right here, this is actually 13. And the reason why I know it's 13 is because XZ right here is a radius, but this is also the radius, which means it's 8 because it's going from the center to the outside. So we've got 13. Now we don't know if these are equal, so we're going to put a question mark. 8 squared is 64. 10 squared is 100. And 13 squared is 169. 64 plus 100 is 164. 164 is not equal to 169, so no, this is not a tangent line. If it were tangent, then this also would have been 169. Sorry, having some issues. All right, now we can also use the theorem to find the value of x, or find a missing leg. So assume that the segments that appear to be tangent are tangent. So they're telling us that these two legs are going to be perpendicular, meaning that they are intersecting at a right angle. So what we're going to do is we're going to use Pythagorean theorem again. And we're going to do a squared plus b squared equals c squared. Now, in this case, our hypotenuse is not going to be 17. It's going to be a whole lot more than that. Because it's 17, remember, you've also got a 15 here because that's the radius. So all of it is going to be 32. And we have to find the missing leg. So the way we're going to end up doing that, and if it helps you, you can go ahead and draw a picture. And you're looking for the missing leg. So C, we already know. I'm going to make 15 be my A. And 32 squared. So we figured out what those numbers are. Do 32 times 32 is what 32 squared is. That's 1024 right here. Is equal to 225 plus b squared. Subtract that 225 from it. And you get b squared is equal to 799, which means b is going to equal to the square root of 799. When it's something weird like this, and I don't expect you to simplify it, then what I'm going to do is I'm just going to tell you to round to the nearest hundredth. And in this case, that would be approximately 28.27. Now, if they had said that this was 15 centimeters or whatnot, then we would say centimeters for this, but that was not the case, so we just move on with our lives. All right, now there are some more tangent line properties that we need to go over. The first one is that if two segments from the same external point are tangent to a circle, then they are congruent. So the bolded parts are the important parts. And what we're going to do is we're going to also mark it up right here that AB is congruent to CB. So let's try it out. We are being asked to find WX. Okay, well, what they've given us that XY is tangent right here and XW is tangent. Now, I know they didn't tell you that. I'm telling you that, and you would be given that information. So what we're going to do is we're going to set these equal to each other because they are congruent. So WX is congruent to YX, which means we can set them equal to each other. And then we solve for x, and I'm going to give you a minute to go ahead and solve for x. And you should get that x is equal to 9. And then what you're going to do is you're going to plug that 9 in to right here. Now, granted, it's not going to make a difference if you plug it in here or here since they're both congruent. But let's try with what they gave us. 7 times 9 minus 29. So 63 minus 29, that's going to get you 34. Or if you did it through here, that would have gotten you 2 times 9 plus 16, which is 18 plus 16, which is 34. Again, wouldn't have mattered which side you picked since they're both congruent. You would have gotten the same thing. All right, last property or theorem. If a polygon is circumscribed all around a circle, then all sides are tangent. So what it means if something is circumscribed. Circum meaning circular, and scribe meaning written. So if there is a polygon drawn or written around a circle and all of these sides are going to be tangent right here. Now, I want you to notice that because of this theorem right here, what we can do is we can state that AD and AF are going to be congruent because they are both tangent and they're both on point A. Same thing can happen there with BD and BE and with EC and FC. So let's try it out. I want you to find the perimeter of ABCD. Make your congruency markings. That'll help you. And I start with the smallest one as my one, just because there's not enough room there. All right, so that's 2.5. This is 17. If this entire thing right here is 21, and only this part is 17, then that means the rest of it is going to be 21 minus 17 right there, which means that would be 4. This one right here would be 29 minus 17, which is going to be 12. And if that part's 12, then this part is 12. And don't forget this part is 4. So all you're going to do now is you're going to add up all of the numbers. If you really wanted to, you could also just tell me how much BC was, which would be about 14.5. And this CD is around 6.5, or exactly. You add up all of those edges, and you can do it that way as well. You should get 71. All right, this one's a doozy. So, first things first, let's mark up what we know is congruent. All right, so in this one, you're going to have to solve for x, because these two are congruent, and you're going to have to solve for y as well. And when you solve for y, you'll be able to plug it in and find OK. Once you find OK in that length, you'll be able to find this length as well. So I'm going to have you guys solve for this part first. So go ahead and solve for x. You should get that x is equal to 9. And if x is equal to 9, then I can plug 9 in into either one of these expressions. I'm going to do this one, which is 5 times 9, so 45, minus 8, and that gets you 37. And if that's 37, so is Jn. All right, now let's go ahead and set nk and ok equal to each other. So we're going to do 7y minus 9 is equal to 2y plus 11. Solve for y. And you should get that y is equal to 4. And since y is equal to 4, we're going to plug it in. So nk and ok are both going to equal 19. And I got that by plugging it in here or here for the y. All right. Now, if OK is 19 and OK is part of LK, then we're going to subtract that 32 minus 19. When we subtract 32 minus 19, we get that this is going to be 13. So then we've got all of the edges, and we're going to add up 37 plus 37 plus 19 plus 19 plus 13 plus another 13. And you should get 138 as the perimeter of this triangle. All right, so apply your theorems and you should be good to go. Thanks for watching.